Good evening, everybody. It is my pleasure to welcome you to the 26th season of C Secret. Tonight is our third lecture of the series, and I am Rami Abissar, the Dean of the Rosenstiel School. So thank you, everybody, for joining us online. Unfortunately, or for some of you, fortunately, we are going to continue this year to have all our presentations online to fulfill the requirements imposed by COVID. As you have maybe noticed, this year we are focusing on bringing the speakers from our own school, and we are trying to cover the 4 strategic initiatives that we have launched as part of our strategic plan. Those initiatives are based on a very important major issues facing our planet and humanity. And that includes feeding the world. And you already heard, for those of you that have been following that, a presentation on our effort in aquaculture and producing food that helps us maintain also the environment. The second topic is protecting our marine resources, and we'll talk more about that in a forthcoming lecture. The third issue is saving lives, and to some extent this evening, you will hear a little bit more about that as well. And the last but not least, it has to do with the fundamental research, and that's unlocking ocean secrets. So these initiatives represent also the cornerstone for our philanthropic support for our school and our fundraising campaign that is starting to get a public face pretty soon. Tonight's presentation by Professor Katharine Mach, you will hear how her research assesses climate change risks and response options to address increasing flooding, extreme heat, wildfire, and other hazards. Through innovative approaches to integrating evidence, she aims to inform effective preparedness and equitable adaptations to those risks. Ultimately, saving lives with knowledge which serves to guide and develop policy. Professors like Katharine Mach provide highly relevant and outstanding opportunity for us to transform students into the next generation of scientists. Students benefit greatly by learning and working alongside with faculties such as Professor Mach. As you have heard me mention before, and I cannot stress enough, just how important scholarships are to our school's mission. Scholarships allows us to recruit not only the best and brightest students to pursue their degree, but it also offers for many students that cannot afford the cost of studying at a private school a unique opportunity to do just that. If you are interested in learning more about how you can help support our students and those initiatives, I welcome hearing from you. You can contact me at an email that our Director of Communication is going to put in the chat. A special thanks to our C Secret sponsors and the many friends who contribute to the Rosenstiel School. So that includes our presenting sponsor, the Bank of America, the Shepard Broad Foundations, Bill Galway, Cheryl Gold, the Key Biscayne Community Foundation, the Key Biscayne Life Enhancement Fund, and the John McCann Family Foundation. Thank you all for supporting C Secrets. As you know, also, it has become a custom now for us to present before the key speaker to show what one of our alumni has become, to emphasize that the students that study with us become eventually very relevant in the field of science and policy. And this evening, I am delighted to introduce to you Galen Troyer. Galen is the Resilience Coordinator for Strategic Outcomes in Miami-Dade County's Office of Resilience. He holds a BA in Economics from Oberlin College and a Ph.D. in Environmental Science and Policy from the University of Miami. He was a postdoc scholar in the University of Connecticut's Department of Civil and Environmental Engineering. As a graduate student at the Abbess Center for Ecosystem Science and Policy at he studied coastal risk management and climate change under the guidance of Rosenstiel professor Kenny Brown. Galen collaborated with faculty and students from the Rosenstiel School, FIU, and universities across the country on the National Science Foundation funded South Florida Water Sustainability and Climate Project. The Rosenstiel School provided a vital interdisciplinary social and intellectual community, which he continues to engage in his work at the county. Please, Galen.
Thanks so much, Ronnie. I am going to get this sharing going. 1 second. Thank you so much. I'm really excited to be back here. As Ronnie said, I am now with Miami-Dade County. I started out, just to give you a little background, I'm from Duluth, Minnesota, another great place on a body of water. A lot of similarities, but the temperatures are entirely different. I went to Oberlin. I spent about 10 years in Minneapolis doing dance and theater. I co-founded Live Action Set, which is a physical theater dance company. And then I found my way at Columbia University doing research on environmental decision-making. There, I ran into this guy who, if you've met Kenny, you know he's a charmer. And he was like, "What? Don't you want to spend some time in Miami doing some research?" And I was like, "Yeah, that's cool. We'll go do amazing adventures." And then I ended up hanging out with this guy with the stuff on his head and really learning who Kenny is. He's great. And he gave me a lot of opportunities to really dig into Miami. I studied the response to sea level rise in Miami Beach. And I got to travel to the Netherlands and do work funded by NSF. I was really supported here to explore and engage and kind of dream about the possibilities of what I could do. And I think that my dissertation is really, I feel proud of it because I have now met multiple people who have said that they actually read it. And they're like, "Oh yeah, I read that." They've asked me specific questions about chapters within my dissertation, which is really satisfying. I went to the University of Connecticut and did some more research on risk in water management and harmful algal blooms, which we really need to watch out for. And then I decided I really wanted to get closer to decisions. And so I was offered a job in Miami that was planned to start on the day that Dorian was hovering out here. So I was driving down to Florida and talking with the county while they were being like, "We're not sure." It's that storm, my God. I was out there. I got to go out to the Bahamas, and it is real impact. The work that folks at Rasmus do, the work that Rasmus folks do out there is really important. I'm going to talk a little bit about Miami-Dade and the work that we do. We have a long history of resilience. It goes back to the early 90s. This is just a taste of the work that we're doing. And I'm happy to talk to anybody about it who wants to. I think we all are. So really watch us. We're an example for the country and the world, I think. We really put it all under the umbrella of Resilient 305, which is a multi-jurisdictional collaboration, public-private partnership to respond to the shocks and stresses that are coming our way, which are definitely being impacted by climate change. Everything is getting worse. One of the actions within Resilient 305 is to collaborate with universities. And under the research collaborative, we are looking to put research into action across the county. That includes professors from the University of Miami, FIU, Miami-Dade College, and we're all working together. I think it's really important that we leverage the universities here and put this active research into work, and then also use our work as at the county to inform where that can go. Another initiative that's happening right now is the Biscayne Bay Task Force. Irela Begay was appointed as the first Chief Bay Officer and is adjacent to, kind of in our office, and is really working on saving the Bay. Critical research is done by Erasmus and by the county. That kind of collaboration is really important. We just released our sea level rise strategy just over a week ago. Please check it out. It's online. It's really great. It's really interesting. Again, building off of research done at the University of Miami in terms of transects and how we divide our community and think about approaches. I'm going to go through all this very quickly just to touch on everything that we're doing. And right now we're working on developing a climate change strategy. As Mayor Daniela Levine-Cava has said, I know we can become carbon neutral by 2050, if not sooner. And that's a challenge that the mayors have put out there because we all have to be a part of it. It's not something that the county can do on its own. It's not something that any of us can do on our own. And I just wanted to say that it is a real pleasure to be here with Katharine Mach's lab. I've had the opportunity to participate some in the research lab that they have, and it's been really great. I'll just say that it's been really great to be able to be both a public servant and keep a toe in the academic world where we're really stretching and growing. I'm excited to hear this conversation. Before I stop, I have to say you should all sign up for our newsletter. It's a great newsletter, and for any of you who are looking for jobs in this field, we have a really good job list that shows up once a month. So go to our website, sign up on the newsletter sign up button, and we'll be in touch with you. Always feel free to email me, galen.troyer@miamidade.gov, and I will get back to you. Thanks a lot.
Thank you, Galen. Really appreciate, and a pleasure to see how you have evolved in your career. It is now my true pleasure to introduce to you Professor Katharine Mach. Professor Katharine Mach has been with us since August 2019, and she's an associate professor and a faculty scholar at the University of Miami Abbess Center, focused on environmental science and policy. Her research, as I have mentioned a couple of minutes ago, assesses climate change risks and response options. Through innovative approaches to integrating evidence, she informs effective and equitable adaptations to the risks. Dr. Mach is the 2020 recipient of the Piers Sellers Prize for world-leading contribution to solution-focused climate research. She previously was a senior research scientist at Stanford University and director of the Stanford Environment Assessment Facility. Before that, from 2010 until 2015, she co-directed the scientific activities of Working Group 2 of the IPCC, the Intergovernmental Panel on Climate Change. This work on impacts, adaptation, and vulnerability culminated in the IPCC's Fifth Assessment Report and its special report on managing the risk of extreme events and disasters to advance climate change adaptation. The associated global scientific collaboration have supported diverse climate policies and actions, including the Paris Agreement. Dr. Mach is a lead author of the IPCC Sixth Assessment Report and the US Fourth National Climate Assessment. She serves as a co-editor and in-chief for Climate Risk Management, an editorial board member for Oxford Open Climate Change, and an advisory committee member for the Aspen Global Change Institute, the Stratospheric Control Perturbation Experiment, and an experiment that is called Carbon 180. Across all of her research projects, she engages in relevant policy processes, and she frequently discusses climate change risk and adaptation with the media, the private sector, non-governmental organizations, and communities. Dr. Mach received her Ph.D. from Stanford University and her undergrad that she received summa cum laude from Harvard College. I have to mention that Dr. Mach has more than 20,000 citations, which for the scientists of us, you will appreciate the importance of the work and the relevance of the works, given the extremely high number of citations of her work. At UM, Dr. Mach is the Graduate Program Director for the Department of Marine Ecosystem and Society, and she teaches interdisciplinary environmental research, introduction to the why and the how, and the science of actionable knowledge. Thank you so much, Katharine, for your presentation this evening. All yours.
Thank you so much, Ronnie, for that warm introduction. And thank you, Galen, for a perfect kickoff, really describing the relevance of the science we're doing at UM. So I also will see how smoothly I can get into the screen share here. Excellent. So over the next half hour, I, along with two PhD students in our group, Nikosi Muse and Lene Turek-Hankins, will introduce our approach and a few examples of the work we're doing, bringing together science and policy as the climate continues to change. In terms of our approach, there are two pillars that cut across all projects. Number one is an integrative view. When it comes to the risks in a changing climate that we need to manage, they are all about interactions. You will hear from Kos and Lene about extreme heat. Well, if we want to manage extreme heat, it is heat and humidity in climate zones that are changing, shaped by geography and urban environments. They're also a function in terms of the impacts of our physiological thresholds for both people and ecosystems, as well as the jobs we have, how well insulated our homes are, and whether we can turn on the air conditioning. All of those different factors have to come together, and we're working with methods of science that are about enabling that type of integration. To paint it in pictures, this theme of integration is about the interaction here between the left side of the slide and the right side. As the climate continues to change, we're seeing many of the impacts arising from the sharp end of the climate system, whether it's the floods, the fires, the drought, the heat waves. But the losses and the damages and the impacts are not just a function of those hazards. They're a function of our baseline and how we respond. Things like building codes and quality, our levels of planning, early warning systems. And on the right hand of this slide, there are thousands of adaptive options that are relevant. And in terms of the challenge of our work, many of these options, when you add them up to a regional scale, carry price tags of billions of dollars. So figuring out how we adapt in a changing climate, really non-trivial because of these interactions that are about very enduring investments. A second key pillar in our work is that we're interested in the ways that knowledge is relevant and usable for societies and decision-making. I think as scientists, we know that when we publish scientific papers, they don't turn into policy all by themselves. So we're really working with some of the themes where science can add value through deliberate approaches geared towards actionable knowledge. I'll describe in a second some of the deeper uncertainties where this is really challenging and really important. In the space of actionable knowledge, you almost always are working with the distinctions and the overlaps between facts and values. So people care about societies and culture and finances and the environment, and often they disagree about the relative importance of all those things that come down to values. And the final aspect here that is a really exciting part of climate change adaptation right now is that at long last, the world is shifting from planning to action in terms of increasing preparedness. As Galen described, South Florida is exhibit number one in terms of implementation happening and the role of science in informing those processes, broadly speaking. So now to come back to this theme of deep uncertainties, perhaps the place it is most relevant for coastal adaptation right now and in our work is the ice sheets. How much sea level rise happens in the second half of this century and beyond is deeply uncertain because there are wide open questions just how stable our ice sheets would be with continued emissions of heat trapping gases. So for science, oftentimes what we're doing is actually working with methods that are responsive to those deep uncertainties to inform robust, smart, effective, adaptive pathways through time. The second key feature of the implementation landscape is that, for public health and the pandemic over the last year, we've been thinking about literally on a daily basis, every time you pop open a newspaper or listen to the radio in the evening, the ways that we have institutions that support interactions between science and policy. So compared to public health, climate change is still emerging. You've got, in the South Florida context, the incredible work by local governments and community-based organizations. You've got the UN Framework Convention on Climate Change, which is unbelievably high level. And in between those, the institutional infrastructure is emerging. So that means there is a crucial role for interactions between scientists and practitioners. And there's a need to be really attuned to the nature of the context. So we're often working in this spectrum between research and practice and the way that science can contribute. There are ethical domains here that are crucially important. Oftentimes scientists think that if they send science off into a community, it will do good. That's not necessarily the case. And so the frontier here is often all about evaluating these processes as well, through which scientists, practitioners, communities are working together through substantive interactions, equitable relationships towards usable knowledge that supports ongoing priorities. So those are the two pillars of our approach, integration and actionable knowledge. I'll now weave them into one area of research, this broader theme of the role of science in supporting transformational adaptation pathways into the future. So I mentioned a few slides ago that there are thousands of things you can do to adapt, to prepare, increase resilience in a changing climate. That's not very helpful though, so I'll give you here a few buckets that are often used, especially for coastal adaptation. So what can we do to prepare? Number one, we can resist, protect, armor, keep water out through things like seawalls or revetments or storm barriers. We're looking here at the Thames barrier, which protects the city of London. In many locations, it's not so much the technological limits, it's about the finances of keeping water out. It's also about the trade-offs in that you often lose coastal ecosystems and divert water elsewhere. A second major category of response and adaptation is accommodating flows of water, elevating infrastructure, elevating where your outlets are in your home. My cherry-picked picture here is intended to illustrate the classic line that accommodation has its limits. There are other categories. You could avoid developing in hazardous places in the first place, but societies in general have not been very good at doing that historically. So the rightmost category here is the reverse of avoiding development in hazardous places. It's removing people and assets from floodplains, or in the context of fire, from areas called the wildland-urban interface. This category of retreat is something where there are experiences, even though to date, most of the focus has been on resisting and accommodating. Okay, so now let's imagine a city, anywhere city on planet Earth. And as we think about the future, key thing is things are changing. Societies are changing, technologies are developing, economies are growing or declining in some cases. And climate change is adding on top of this picture of socioeconomic change through time, altering, constraining the range of possible futures. How much is climate change shifting the future for coastal cities? Well, if we think about sea level rise under continued high emissions of heat trapping gases, the global sum total for all cities on planet Earth on coastlines is an exposure of about 88 million people, up to 1.4 billion to displacement from sea level rise by the end of this century. So up to 1.4 billion, that's a lot of people. The next question would be, how might societies grapple in terms of those categories of resisting, accommodating, retreating? Economic analyses suggest that for about 13% of the global coastline, the cheapest response to minimize the total cost of sea level rise is to keep water out, 13% of the global coastline. Those areas are the high income, more urban parts of our global coasts. By contrast though, for 65% of the global coastline, the cheapest thing to do is to just let land become abandoned, a according to economic analyses. Those are mostly found in low-income rural areas. So that, in a way, is the challenge when we think about a city somewhere on a coastline heading into the century ahead. The range of possible futures is wide, and response to climate change and other factors simultaneously is basically inevitable. But the real questions are how and why we adapt, how we ensure safety and well-being for people and nature into the future, recognizing that the needs and the potential for adaptation fundamentally depend on our progress with reducing emissions of heat-trapping gases. To focus in on a few of these possible futures, on the leftmost example, we see a world that my colleague Siders and I call hybrid, a world where there's some resisting, there's some retreating, there's some accommodation, but the retreat in this world is rather laser-like, creating retention ponds, pumping, canals. The center world is one of transformation of infrastructure and behaviors, a Venice-like world where roadways become waterways and people take boats to work. The rightmost world here would be a future that would be a landscape-based approach to enabling ecosystems to be conserved, land-based livelihoods to be maintained. So across all of these different examples, the really key thing I want to emphasize is that these major categories are all occurring. In the space of coastal adaptation, oftentimes response options are pitted against one another. Do we keep water out or do we retreat? With retreat not popular. But actually, in many of the places that have successfully managed water in coastal environments to date, it's been all about a combination of different categories of responses, and we really expect that into the future. And the key thing, though, is that all of these adaptation options for resisting, accommodating, retreating are tools. And the thing that really matters, though, is the goals to which these tools support societies. That can be economic, about reducing disaster risk, supporting social cohesion, environmental priorities. So much of the work of our research group is tackling different parts of this broader landscape, thinking about the transformations underway, the way that climate change shapes what may happen into the future, the responses that are unfolding that may change into the future, and how they can support societal priorities. I'll mention one example in a bit greater detail, and then I'll close out before handing to Kos and Lene with just a return to this and description of some of the other areas we're tackling. So one major area of work has been on retreat, because this is something that can expand the option space, even though it is so controversial. Political suicide, socially not what you want to throw out there on the priority list, even though it may have a real role in expanding the effectiveness of everything else that societies do. And what's interesting is that actually a lot of retreat has happened globally to date in response to natural hazard risk. In about 20 countries, over 1.3 million people have moved through different processes of retreat. In this study, we did a systematic review of about 27 different cases that have been documented. So in some cases, the upper left-hand image here, for example, it's been a small number of households that have been moved out of floodplains with that land returned to open space. In this case, it wasn't so much about protecting those households, but protecting a much bigger settlement downstream, the greater good. Residents weren't wanting out, but they got out through a long process of engagement to protect the city of Rotterdam, for example. In the bottom right-hand corner, by contrast, this is how we've seen retreat unfolding in Alaska, Louisiana to some degree, where indigenous communities for decades now have been requesting to move. In the circumstances of the indigenous villages in Alaska, the US government mandated their locations of settlement in the first place in highly hazardous locations where the permafrost is now melting, the sea ice is thawing, storms are coming on shore. These have been very, very slow processes of retreat with a whole lot of challenge in terms of getting coordination across many different levels and agencies of government. The top right corner is an image of what's called a voluntary property buyout. So a home has been substantially damaged in a flood. The homeowners decide voluntarily to sell that property to the government at the pre-disaster price of the home normally, and the land is then returned to open space. So across these many different examples of retreat to date, there are rightly many concerns that have been raised around equity. Who's offered a buyout versus who is not? Are historic wrongs recognized in something that is as complex as retreat? tied to home, the center of our psychological existence. Retreat has often been incomplete, focusing on some hazards, not others. And in many cases, it is looked at flooding risk isolated from the much broader set of priorities that people have. For example, some research we've done has focused in particular on how buyouts have unfolded across the United States. They've occurred in 49 states, 3 territories, over 1,000 counties, over 40,000 buyouts in total. And what's interesting is that these buyouts are happening in places that are at risk of flooding, but otherwise they actually contrast what you'd expect from those earlier economic analyses I mentioned in terms of what might happen for sea level rise adaptation into the future. So here, the surprise, or maybe it's not so surprising, is that the places that have done buyouts tend to be higher income, more urban areas. Counties that have implemented buyouts are those in the orange color, the distributions to the right in each of these plots. By contrast, though, the zip codes or the neighborhoods where the buyouts have happened are lower income, less population dense. So these left images here, that implementers of buyouts have been higher income, more urban, contrast the expectations from economic analyses, and the right ones, in terms of these plots, corroborate some of the concerns pointing to the importance of evaluating equity. So although unmanaged retreat is absolutely to be avoided, I think the real question is how so many of our different options come together in creating futures that are all about supporting goals, priorities determined by communities across our global coastlines. Other work we're doing in this space is quite diverse. One collaboration that spans between UM and FIU and UF and also the UCs is looking at risk screening tools to think about those directly affected by sea level rise, vulnerable to adverse impacts of our individual and collective responses, really the nexus between climate mobility, gentrification, and displacement. Other work we're doing is focused on making people whole after something like retreat occurs. How do they fare in terms of the goals they had, where they move, whether they would ever think of doing something like this again? We're also developing new approaches to collaborative flood modeling in combination with decision support methods, exploring the degree to which transparently understanding what your flood risk is and which response options you might want to advocate for might change some of the power structures that have historically hindered transparent understanding of flood risks and responses related to many of the floodplains that exist across the US right now. We're doing communications research on how climate change becomes part of our lived stories, experiences, and narratives in society. And also finally thinking about design and architecture and the role of expanding imagination in terms of possible futures and the distinct possibilities for both research and practice in doing so. So putting these pieces together, there is a large role for actionable knowledge in climate change adaptation, tackling the immense coordination challenges across levels of government, across regions, between the public and private sector. We're looking at approaches that tackle multiple hazards changing simultaneously and that go far beyond disaster risk to stretch into social and economic and cultural priorities much more broadly. And finally, we're working on this question of if and how societies may choose to be proactive as compared to flat on their feet as the climate continues to change. So what I will do now is transition to 2 PhD students who will introduce some of the work they've been doing on extreme heat and adaptation. I'll introduce both of them together and then they will kick it off. Both are PhD students in environmental science and policy at Rosenstiel and Abbas. Nkosi Muse initially studied meteorology in his bachelor's degree and then went on to study geosciences and climate policy for his master's. He's had a very wide range of research experiences in university and federal research contexts across the US before starting his PhD this year, which is a very good thing because starting a PhD in a global pandemic is not easy. His work focuses on equitable adaptation in cities, and in his spare time, he is an avid communicator of science, also weather. And I'll also mention just for fun that as a former Division I track and field athlete, he also lets us know that he does things like practice backflips in his spare time, which I think really speaks to the level of focus and determination he brings to his work. Lene Turek-Hankins did her undergraduate degree in mechanical engineering and the thermal sciences. All sorts of neat projects were part of her work, building automated thermal batteries or this remarkable robot that could swim, leap out of the water, and then waddle on land like an amphibious platypus. She builds from that engineering background now, working at the nexus of energy and climate justice and heat adaptation. And although she has been publishing her research at breakneck speed, I can hardly keep up, today what she'll be doing is looking more towards where she's going over the next few years. In her spare time, she is a talented artist, and I think it really affects the level of creativity she brings to both science and engineering. Okay, Kos, over to you.
As Katharine alluded to, I'm one of two of the super hot heat duo that I hope that, Lene, I hope you can co-sign that name I just came up with this for. But thank you, Katharine. Happy to talk a little bit about my lens on urban heat analysis. So urban heat analysis can be done a multitude of different ways, but across all these different methods, it requires us to measure temperature. And that can also be done a lot of different ways too. So you see here a temperature sensor on top of a building in an urban area. So we could essentially place temperature sensors across an urban region or across an urban city, put them on top of buildings, put them at street level, put them in people's homes, and essentially measure temperature across a certain period of time. But we can also enable citizens to usually do something we call, like what we like to call citizen science, because we can measure temperature on our phones now. And using that data, we can analyze it and see how people feel temperature at their own level. And then we can also do something that's very, very fancy, and utilize something called satellites, which essentially take pictures of this planet, of the planet's surface, and we can use that to estimate LST data or temperature data from space. So this is the method I'm going to elaborate on a little bit more. So with using super technology like satellites comes limitations, and some of these limitations are not limited to being that satellites can only take so many images of the Earth at a given time. So for example, satellites are technologies just like phones. They can probably only hold so much storage at a given time. On top of that, satellites orbit the planet at given ranges of time as well. So one satellite I work with only orbits the planet at every 2 weeks. Another satellite I work with only orbits the planet every day, or orbits the planet every day. So we have to take that into consideration when we also do some heat analysis using satellites as well. And then satellite resolution is also important. What is it that we want to look at and at what resolution? How close and how far do we want to zoom out? And then lastly, technology is technology. So we rely on it very often, but technology also fails. I have not run into any failures with technology or satellites yet, but there's always the possibility that it could happen. So after Bugs Bunny isolates the state of Florida from the US, we end up with the state of Florida. We could zoom out and look at the entire state of Florida if we wanted to do an LST analysis or a temperature analysis of the state of Florida, but that doesn't tell us exactly what we want to know. So when our satellite orbits over a region like Miami-Dade County, we can take a picture, and that picture essentially looks like this. A screenshot of the Earth. So this is nice to look at, but it doesn't really tell us enough when it comes to temperature data. So we do a few calculations, and we end up with something that looks like this. Now, what you see is a less pixelated image and an image that has a little more details too. You can actually see features of the urban form, such as highways. You can see Biscayne Boulevard, if you're familiar with Miami-Dade County, going up into the north. You can also see buildings and bodies of water. And if you're familiar with how Miami-Dade looks on a map, you can probably identify what it is you're looking at here. But this still does not tell us enough about temperature when it comes to Miami-Dade County or urban forms. So that requires us to do a little bit more calculation. And when we do that, we end up with an image that looks like this. So now we have an image of October 22nd, 2016 that represents land surface temperature, or LST. So what land surface temperature is essentially a representation of the amount of energy or radiation that's coming off the planet's surface. So if you're walking over pavement on a very, very hot day, think of the pavement to be black asphalt. You can probably feel the energy that the same energy that the sensor on the satellite is actually corralling when the energy comes from the planet's surface to the satellite sensor. So when you're walking over that surface, you feel that heat, especially when the sun's beaming down all day. And that's essentially what we're looking at here. So when that satellite is beaming down towards Miami-Dade County on October 22nd, 2016, this is what it gets back. And we see that there's hot spots characterized by warmer colors, and then we see there's cool spots characterized by cooler colors. You can also see that in the bottom right corner, there is a cloud. And if you look in the top left corner, you can see the difference in temperature, 48 degrees Celsius to negative 125 degrees Celsius. I promise you we're not experiencing any temperatures near negative 125 degrees Celsius, but the top of the cloud that you see in the bottom right corner happens to be very, very, very cold up top, and that can skew our data a little bit. We can also look at different days or capture different scenes, like this one. So on August 19, 2016, this is what it looked like. Now, this doesn't really help us much because it's just hot everywhere. So there's not much we can really do with that. But another limitation here is that you see clouds everywhere, and these cloud tops essentially interfere or skew the data. So that's another limitation that we have to think about when it comes to using LST or satellite observations. So it's nice to have those images, but we need to know what we're looking at when we're looking at LST data. So now if we take a snapshot of a specific region like Miami-Dade County and overlay that over a map, you can see the LST from January 13th, 2018 here. And you can see the urban form. You can see places that are essentially this open land. You can see where the roads go through in Miami-Dade County or the city of Miami and its neighboring jurisdictions. But this still doesn't tell us enough. We want to zoom in even further. So we can do that by overlaying something like census tracts over the image. But there's a lot of census tracts. And on top of that, these census tracts tend to be pretty big. So we can zoom out just to zoom back in further. And we end up with an image that looks like this. So this is the city of Miami's land surface temperature observation on October 22nd, 2016. So we're zooming in further and further as we go here. This is nice to look at too, because it gives us a blob of LST, but we can get even more specific and we can do something like this, overlay different neighborhoods over it in order to see, okay, which neighborhood may be the warmest in the city of Miami. But to really, really know what we're looking at, we have to play around with the data a little more. So we can do something like this. What you're looking at now is an average of LST within each neighborhood here. So the average LST is characterized by different colors. And there's two very, very hot neighborhoods that we can see here that are characterized by the reddish colors that you see here, the Alapata Industrial District and the Fashion District. But we can also look at areas of expertise or areas of interest, because these two may not be the hottest areas every day on October 22nd, 2016, like it is for the rest of the year. So we can look at areas like Overtown. Overtown is a predominantly Black neighborhood or a marginalized community that really doesn't have the same resources or affluence to afford climate change or heat resilience measures when it comes to other different places in the city of Miami. So if we look at areas like this and we look at the entire, in general, Miami-Dade County or cities or different neighborhoods in the city of Miami, we can say, okay, this is a region that is very warm on this day or over a period of time, and we can use that to inform equitable and inclusive policy for heat resilience planning. So with that, I'll throw it to Lene.
Hi, everybody. Yeah, my name is Lene. I am a second-year PhD student at the AMA Center studying environmental science and policy. And Kos, I'm so supportive of the heat duo name. So hoping to see that moving forward. In my research, I study how people are adapting and preparing for climatic hazards. And very specifically, I think about the intersection of housing, energy access, and security in the built environment. And like Kos, I'm really interested in heat. And one of the reasons I'm so interested in heat is because it is fundamentally a hazard of inequity and inequality. And you can really tell by the way that we are adapting to heat. For most of us, when it's hot outside, we just turn on the AC and that's that. But the reality is that's not possible for everybody, whether that's economic reasons or they just don't have a great AC unit that's functioning. And so really thinking about what the adaptation options are for them is really important. And so in my work, I have looked previously, like Katharine said, at the thermodynamics of buildings and the built environment and really what the heat properties are of structures. And I'm hoping to translate this into my PhD work, as well as thinking about methods like econometrics, which is basically a fancy word for statistics of causality. How can we really robustly think about the relationship between policy and impact and tying that together with climate change? So I'll kind of walk us through this together. So first, let's talk about the built environment. And Kos really set us up for this. The built environment is basically what are the materials that make up your neighborhood. So I have two images here from Google Street View of streets in Miami. We have on the left Little Havana, and on the right we have Coral Gables. And so in Little Havana, we see there's a lot of asphalt, a lot of buildings that don't really have shade coverage, and really not a lot of trees in general. And we can contrast this with Coral Gables, and we see lots of shade, lots of canopy coverage, less impervious surfaces on the ground, a lot of more dirt and grass, things like that. And it's not really hard to understand why, if you were standing in Little Havana, you would be exposed to more heat than if you were standing on the street in Coral Gables. And so a big part of heat exposure is what neighborhood you're in. And this ties back obviously to different racist policies that have happened, as well as economic differences. So the next aspect is energy security. And in the United States, we consider a home to be energy burdened if it spends 6% of its income on its energy bills. So on this color bar on the right-hand side, we can see that a home would be energy burdened if it's that aqua color, which is the second to the right color bucket. And on the left, we see an image of Miami-Dade County, different neighborhoods in Miami. And we see that there's actually a lot of neighborhoods where the average resident is energy burdened in Miami. We see in and around Hialeah and down at Homestead as well. And so energy security is really important because that's the question of, are you actually able to pay for your AC bill? Are you able to make sure that your food is kept at a safe temperature and that it's not going bad and you're not having to spend a lot of money repairing or replacing that food? And then the last piece of the puzzle is housing. So it could be the case that, okay, yeah, you can afford your energy bill, but is it prohibitively expensive? And a lot of that comes down to if you have a really old unit. And that could also be an issue of if that unit is safe to use. So I know mold is a significant problem for a lot of old AC units. And another thing to think about is how well built is your house? So even if you're paying for AC, it could be really expensive if your house is poorly made, if there's not a lot of insulation, or if you have problems with fenestration, which is a fancy word for air leakage, which is air coming in and out, places that it really shouldn't be coming in and out of. And the other piece of this is thinking about survivability. So if there wasn't power, how long could you stay in your home at a comfortable temperature and not have to worry about having health problems? And so we can think about this now from a national perspective. And this is not a problem isolated to Miami. And here we see an image from 2019 that actually was in New York. And there was a heat wave that led to an increase in demand of power because of need for AC, which led to planned power outage. So this is not a thing that doesn't actually happen in real life. And then another example we can see is in 2020. So one of the big concerns out west is wildfires caused from the downing of power lines. And so a lot of times the power companies will shut off power to avoid the risk of fire. And we saw an example of that coinciding with a heat wave in the COVID-19 pandemic. So here we have a case where the government is literally asking people, hey, stay at home. Also, you don't have any AC during this heat wave. So it's a really dangerous situation. And then finally, although the connection to climate change is slightly more tenuous, we see a different climate extreme, and that is extreme cold very recently in the state of Texas. And in this case, again, power was shut off because too much demand. The grid was not able to handle the extreme temperatures mixed with that demand, and people had to suffer at home and deal with these climatic temperature extremes. And we also saw this impacting their housing because things like pipes were exploding left and right. And so just kind of going back, what I'm really interested in focusing my PhD on is this intersection, housing, energy, and the built environment, and climate change, and what that means for adaptation options. Thanks.
Thank you so much, Kos and Lene. And now we all, Galen, Kos, Lene, and I are all open for questions. So Ronnie, over to you.
So thanks, Katharine, and the two great students that you have. Really appreciate. Before we go to the question, I just have a little bit of information to pass. The first one is if you are interested to support our mission, which is, again, very important, we are going to put in the chat box the best connection to do that, okay, through our website. There is also the next presentation is going to be on Tuesday, March 30th at the end of the month, and that will be given by Professor Diego Learman and Professor Andrew Baker from the Department of Marine Biology and Ecology, and they'll be speaking on the coral reef restoration project that they have. And again, you can register with the link that is going to be provided in the chat box. And with that, we can open it to questions. So Jennifer and Diana, all yours.
Perfect. Thank you everyone so much for your questions. And thank you so much to Galen, Katharine, Lene, and Kos for your wonderful presentations. I have a couple questions that I'm going to start with Katharine, specifically more on the retreat side of things. I have 3 questions that I will, I'll just give you all 3 at once, and then you can decide if you want to answer all of them together. They kind of overlap. One attendee pointed out that it seems that implementing equitable retreat will require some transformation of how we currently place community values, such as we're going to have to move away from relying on the perceived economic values or the property values and move more towards attributing value, different ways of attributing values. So given how entrenched property values are in the status quo, cost-benefit analyses, and especially how big of a role property values play here in Miami, what does the future of equitable managed retreat and a new way to determine benefits and trade-offs look like? I guess taking into account not just the economic sides of things, but environmental and also societal considerations. And then the next part is getting to that same best case scenario. What do you think some strategies could be to enable retreat to be financed on a larger scale for Florida? So what roles do personal insurance, funding from the state and federal government play? And then just one more question. Is there any way of knowing which one of those 3 managing the response options that you mentioned of the resisting, accommodating, and retreat? I guess what is your thoughts of knowing when to use which of these methods or the combination of the 3 should be implemented, especially taking into those all of the holistic community impacts, the environmental, societal, and economic?
Okay, perfect. And I'll be as brief as I can to make sure we get in more questions as well, because I could easily spend a half hour on all of these rich themes. So I think the first point around cost-benefit analysis has had value. It clearly has value into the future, but it doesn't work very well when narrowly defined and equity considerations are relevant. So the basic rub is that if you look at where we have protected infrastructure to date, if you protect $1 million home, the cost benefit returns end up looking better. And that's a real problem in terms of how funds have been prioritized historically. So on the one hand, that points to the crucial importance of much more holistic processes of valuation. FEMA certainly is moving in that direction very rapidly. There's a wonderful new report out that they put on themes there. But I think really adaptation from within that is not just about protecting the costliest homes is the billion-dollar question in this space, and there's a big need for innovation. I think the broader question for finance, frankly, goes far beyond retreat. You know, whether it's Florida and flooding and sea level rise and hurricanes, or California and fires, literally you can go down the ledger, and many of the major infrastructural features of our landscape that are affected, the cost tags, the cost price is just enormous, whether it's our roadways, our septic systems, our power lines. Figuring out how we finance adaptation globally is a major challenge now, and I think one where we can look to many innovations coming into play, but it is the billion-dollar question, and frankly the trillion-dollar question in terms of innovation in the landscape of adaptation moving forward. And then I think the last question would be, you know, maybe just an interesting example to put forward would be that the Netherlands might be the one place globally where we can say they have managed sea level rise and flooding over decades now. Venice actually has had 3 feet of sea level rise over about 500 years. So there are a few examples that we can look to, and we have seen massive transformation. We know what Venice looks like. It was always water-based, but actually the water used to be 3 feet lower, and that's relative sea level rise as subsidence has happened simultaneously. In the Netherlands, they would never say they're doing retreat. You think of it as fancy infrastructure, but actually it has been an all of the above strategy. So I think the crucial question moving forward is where finance is limited, how do you get to an option that is just strategic and not just something that is unmanaged and about losses and damages unfolding without vision and direction and priorities that are coming from within.
Perfect, thank you so much. And actually building from that, one attendee is asking, based on the Army the Corps' Back Bay report, it seems that they de-emphasized retreat as a viable option. How do we make retreat less of a taboo topic and less controversial, especially since we'll need to discuss the topic, have that conversation out in the open in order to avoid unmanaged retreat, as you've been mentioning, and head more towards equitable options?
And I could answer again, but Galen, do you want to take on the theme of how to talk about the full portfolio of response options as Miami-Dade is doing so effectively in your newsletter and strategies?
Yeah, I mean, I'm not going to say that this is easy. This is hard, right? Like the first thing is this is hard work, and there's no easy solution to it because we have to live in this. So the way that we are approaching it is with our sea level rise strategy, which I put a link to it in the chat, and it essentially provides 5 ways that we can, 5 approaches to being able to stay here in Miami-Dade. I mean, let's be honest about it. Miami-Dade County's average height, or half the county is below 10 feet. That's really the situation. So we're in a narrow space, and we're going to figure out how to stay here. I mean, I can say when I first came down here in 2012 and saw the projections, I thought, man, this place is going to, like, the real estate market's going to fall off a cliff at some point, and it's going to go the way of Detroit. That was really like the thought that I had. And having done a bunch of work here, I think that it's clear people are going to stay in Miami for a long time because they don't want to leave it. It has a unique climate, a unique culture. We have a lot invested in this place. And so we're looking for ways to do that. I think that is like the most honest answer that I have. And we will be inventing it all the way, coming up with new solutions and looking at different approaches. But right now, just a few days ago, honestly, we laid out an approach that the county is taking. And it offers a real focus on specific items that we want to invest in. And then it also offers up 5 different ways that you can go at that, which actually overlap a lot with the work that Katharine presented, which is really interesting.
And we didn't just copy the strategy, I promise.
Yeah, no, it's interesting. I just got a text from one of my coworkers who was like, "Oh, that's very interesting how related these are." So yeah, I'm going to stop there and let some more questions.
Jennifer, maybe just one last question for Lene and Kos.
Perfect. So we have one question asking you to expand upon the connections between specifically society impacts and the climate risks. Lene, Kos, you went into details about the heat and how they can impact communities, but specifically here in Miami, how can we address these impacts and how they will affect the community on a society level? And how can we make sure that we take our planning into action to address and make sure that all the communities are heard and taken care of?
I think something that's very important is that we need to empower our communities, not only with education about the threats that they're facing, such as extreme heat, but they're experiencing it every day. They're the ones that are experiencing it, and we're in the science community and we're putting out solutions that don't match what they feel or what they see, then something's not adding up there. So I really think that a priority that we all need to, as scientists, do is make sure that we're involving the community in the decisions that we make, making sure that the things that we're doing, they're aware of. Then also using their indigenous or their local knowledge to tell us, okay, we know this area tends to be hotter. What can we do in this area to help you, walk to the bus in a more comfortable manner, wait for the bus in a more comfortable manner, not have to blow my AC all night, and worry about my power bill going up and things of that sort. And with that, I think that's a good segue to give it to you, Lene.
Yeah, perfect. I think my response to this question is there are already so many technologies and solutions out there that we know work, and we just have to do them. And we know if you help people with having more weatherized, efficient houses, that's going to have a really big impact on their health. And we know that people who live in poor quality housing are poor, and to be Black and Brown Americans and general socially vulnerable populations. So there are strategies out there that we know exist. It's just a matter of whether we are prioritizing them or not. And I think the other piece of the puzzle is thinking about exactly what Kos was talking about, prioritizing strategies and solutions that people want. So are we actually solving the climate problems that are affecting the people of today, not only the people of 50 years from now? Because I think that is where the equity problem comes in, is that even today there are problems people are having with heat. There are problems people are having with being able to live in a comfortable environment. And that's not an issue just for the future, that's a current problem.
Thank you all so much. Thank you to our speakers. Thank you to all of our attendees for being here. Please join the next Sea Secrets on March 30th. Thank you so much and have a great night, everyone.